Good afternoon, everyone, or morning or evening or wherever we're located throughout the world. Let me get the share going here. My name is Scott Clayton, and we're going to be going through the second session of the Catalyst 900 Wireless Migration Series. Hopefully all of you were able to join us 2 weeks ago for the beginning session. This is session 2. We'll have several more coming up later on, which I'll go through here in just a second. But if you weren't able to join us last time, hopefully we were able to review the recording or go through the slides and go from there. So we'll be building on top of that today. All right, let's go ahead and get started here. So here is the migration series, as I was just referring to. We had the first session 2 weeks ago, and that was kind of the kickoff to the AirOS to iOS XE migration that a lot of our customers have been running through over the last several months, and will be continue running through over the next several months, I'm sure. Today we're going to be talking about FlexConnect deployments and migrating your FlexConnect deployments over to the Cat 9800. Coming up after that, we'll have a 9800 Cloud session in 2 weeks. Then we'll also have in March 11th the migrating from Prime infrastructure to DNA Center. And then on March 25th, we'll have a troubleshooting tips and tricks, which I know I'm actually looking forward to picking up some pointers there as well. And then finally, we'll wrap things up with a hands-on lab. There have been some additional lab sessions added to this, so if you were waitlisted or didn't get in initially, try again. We should have some additional availability or additional spots for those coming up too. And then finally, the last thing I'll point out on this slide here is that all of this information is located at that link at the very bottom, the cs.co/9800 migration. After this session today, the slides that I'm presenting today will be uploaded there. We'll also have the recording from this presentation as well listed there. So if you have colleagues that weren't able to join you or want to go back and listen to something, make sure you got it correct. You'll be able to go back and listen to the recording of this as well. All right, let's go ahead and get started. So my name again, Scott Clayton. I'm a TSA or Technical Solutions Architect at Cisco. I've been at Cisco for a little over 20 years now. I've been in the wireless industry for a little over 10 of that time. Specifically, I've been focused on the wireless side of things. And with me, I've got Ray Geyer as well. He's also an architect here at Cisco. We've both been doing wireless for a long time. In addition, we do have a esteemed panel sitting in our Q&A on the WebEx with us as well. I would guess we probably have a little over 200 years experience in that room. So if you do have any questions throughout the day, please feel free to use the Q&A panel to ask any questions, and one of our experts in that room will be able to help you out. All right, let's go ahead and get started. So here's a quick look at our agenda today. I'm not going to read this over to you guys, but we're going to be going through several different things, kind of looking at FlexConnect specifically. We're going to review FlexConnect, talk about what it is, look at some branch designs. And then ultimately, we're going to get down to how do we start configuring this and what are best practices that we recommend from Cisco when we're looking at FlexConnect deployments. All right. So a couple things we wanted to point out here, and this is not an exhaustive list by any stretch of the imagination, but these are kind of some of the things that you may want to consider when looking at your branch design for wireless. And what you're going to want to do with that. So, central IT, local IT. What is your IT presence at these branch sites? Are we talking about single site, multi-site? What number of branches do you have? Employees, devices per branch. Are these large branches, medium-sized branches, et cetera? There's a number of different things that we want to take a look at. And again, this is probably another 24 things that you could think about and add into your consideration list. But this is just a quick subset of things that we recommend looking at when you're starting to get into your branch office design and how you want to roll wireless out to these locations. Oh, sorry, I went ahead too far there. Okay, so when we're looking at branch office design, there's really kind of three main schools of thought, and I'll get into each one of these in a little bit of detail. But the first one is kind of going from left to right, is having a local controller at that site. That's where we would put a local controller at the site. It would manage the wireless at that site. So you'd have distributed control plane at each of your branch locations. Another option a lot of customers take a look at is the embedded controller option. So we do have the ability now to embed the controller functionality into some of the infrastructure that may already be at that location. And there are certainly pros and cons to that as well. And then the third option that you do have that you want to consider when looking at a branch wireless deployment is FlexConnect. And that's where we're going to centralize the wireless controller, and we're going to manage the APs from that central location across the WAN. And then down below, obviously, you still have all of your automation capabilities within DNA Center, policy from ICE, CMX, et cetera, can be a shared infrastructure across all of these designs. So when we're looking at, let's take a look at each one of these in a little bit more detail here. When we're looking at the idea of having a branch office with a centralized control or with a controller at each location or dedicated wireless LAN controller, we do offer some smaller sized controllers for these. So the 9000L does 250 access points. We can look at some of the CL options, which are the cloud-based options, which do a little bit smaller, less of a footprint, allow for a smaller controller deployment to manage the APs and clients at those locations. When you do that, it's obviously you get the best of kind of the all worlds here, is that you have the ability to do everything you want from a layer 3 roaming perspective at each locations. There's no limitations on the number of APs that are there. You have full control for that. There's no dependency on the WAN. If there are WAN failures or WAN issues or data center dropouts, things along those lines, they don't affect the access points of the wireless at that location. Now, the downsides, obviously, is that you have a WLC at each site, so you have a higher capital cost, and you potentially have higher OpEx as a result of that. So when you do have lots and lots of branches out there, if you're managing thousands of different locations, sometimes putting a physical controller at each site is not really feasible. The second option we do have is with the embedded wireless LAN controller, and we've come out with the ability now to run the wireless LAN controller on the switches at a site. These are supported on the 9300s, 9400s, and 9500s. Excuse me, in SDA fabric mode or non-fabric mode, and that is a new support as of 17.3 that you can run the embedded wireless controller functioning on the Cat9Ks in non-SDA mode. We also offer the ability to run the embedded wireless controller on the Cat9800, on the Catalyst access points. So the access points that you may have out these locations, you can actually run that EWC ability on those APs, and those APs can manage other APs at that site. So without having a discrete controller, we can manage some of that. So when you look at doing that, obviously the pros here, no separate appliance when we do this. We're leveraging the infrastructure that already exists at that location. There's full control, no dependency on the WAN. If there are WAN outages, it does not affect the wireless at that location. When you're looking at the EWC on the Cat9K, again, like I said, it's SDA Fabric, so that's SDA software-defined access mode. But we also now support it in a non-SDA mode, but that is only for a standalone site, is kind of the design there. EWC is AP, is local switching only, so it does not do any kind of centralized control. All the data plane would be dropped off locally right off the access points at the locations, just like FlexConnect does. And EWC also has a limitation on the AP of 100 APs max. On the switches, it's 200 APs max. So again, it's going to be more designed for smaller scale sites, but you will have management points at each one of these locations. And that brings us to FlexConnect, and this tends to be one of the more popular models that we tend to see with branch deployment and management of that wireless at that branch. In this case, what we're talking about here is the ability to put the controller at a central control point, like a data center, as an example, whether that be an on-prem data center or, in some cases, maybe it's a cloud-based provider that you work with that has all of this location, all the control at that location. In this case, what we do is we break out the control plane and the data plane in the site. So what we'll see here is that the control plane goes back from the APs back to the controller at that data center, but the data itself, the actual traffic that's traversing from the wireless clients onto the network stays local at those sites. That's kind of the beauty of what FlexConnect offers. So you get the wireless controller at a central site managing as AP, so software updates, all of the functionality as far as channel and power assignment, things like that are still managed by the controller, by that centralized control point. Clients in the branch roam independently when we do this. So looking again, kind of some of the rules and limitations we do have when we look at this is each site can have up to 100 APs in FlexConnect mode for this, for seamless roaming, and we'll go through some of the details around that. If you do have sites where you have more than 100 APs, we would just need to create multiple site tags to allow that to happen. There's layer 2 roaming only, so that is a stipulation that we do need to make sure everybody understands when we're looking at FlexConnect. If you do have a requirement to roam across layer 3 boundaries, that is not supported in FlexConnect mode. The controller would need to be local for that kind of support. And it also supports standalone mode. So let's say we have a WAN outage or lose connectivity to that wireless LAN controller. Those APs will move into what we call standalone mode and still be able to operate and serve clients even when they're in that mode where they're not directly connected to the AP or to the controller. Highly scalable central management, really ideal for cookie cutter branch type configurations. If you have situations where you're managing a lot of the same sort of branches and they're all kind of set up the same way, is a perfect scenario for FlexConnect. And since the session is called Migrating to FlexConnect, we're going to spend the vast majority of our time today talking about FlexConnect. But I did want to introduce kind of the other options that are available for branch wireless deployments. All right. With that said, let's get into this. So I kind of want to take a step back here and make sure everybody has an understanding of FlexConnect. And I'm not going to spend a ton of time on this, but I did want to make sure that we do have level set here on how some of this works. So when we're looking at the way that FlexConnect works is we have that centralized controller. What we do is we split the control plane up into, or the management and the data planes are split up here. So in this case, when we're talking about the data plane here, for what we can do is we can do central switching or local switching for that data plane. So we can choose it based on the SSID. If we want that SSID to go back to the controller, back to that data center, and be centrally switched, we can choose that for that to happen, or we can do local switching where that traffic stays local at the site for that particular SSID. And when we're in this mode, the APs are in basically two modes. One is either connected, when that AP can talk to the wireless LAN controller, or it goes into standalone mode when that AP is not connected for whatever reason to the controller. So you need to make sure you kind of understand the terminology related to all four of these things. We even create a little glossary here. And I'll just leave this here for reference in the slide deck for you guys to take a look at later. But this is where we talk about the different modes: connected mode, standalone mode, central switching, and local switching. So these are the four main things when you start looking into FlexConnect that you're going to end up configuring. So let's talk about configuring FlexConnect local switching here. So again, 2 weeks ago, Drew and Kair did a really nice job of kind of walking through some of the differences from the AROS model over to the Cat9800 or the IOS-XE model. One of the big things that we see with this is actually with the Flex configuration, and it's become a lot cleaner in how we do things in IOS-XE. You can kind of see here, if you look at over on the left, this is what the AROS model looked like. We had network policy in a lot of different places. You want to create a Flex site or put a branch office into a FlexConnect mode, you essentially had to create a lot of different configuration, a lot of different spots. So some we do under the WLAN, some we do under the AP group, some we do under the Flex group. What we've tried to do with IOS-XE is clean a lot of that up. So now when you start to look at this, the way the network policy is actually generated now is done in that policy profile. When you start looking at the next section here, we add the Flex profile into this, and then we also add the RF capabilities into this. All these get built out into various tags. So the first one is your policy tag that gets applied to that access point. The second one is your site tag. So all the site-specific settings and things around Flex are going to be part of that site tag. And we'll talk a lot more about the site tag as we go today. And then the final tag that gets applied to that access point is the RF tag. If you did not get a chance to review this before, I would recommend going back and reviewing the presentation from 2 weeks ago. It talks a lot more in detail about how all these tags work and kind of the methodology behind it. But it does make a lot of sense when you start looking at this to create sort of templates that we get to reuse over and over again. And just a little bit more here around that model config. All these tags get applied. So this is how the AP is told exactly what we want it to do. What WLANs do we want it to advertise? What do we want to do with that information? What's the information around that specific site that we want to leverage, and then what kind of information from an RF perspective do we want, from a 2.4 gigahertz to 5 gigahertz channel coverage, the different things it does with the RF, what do we want that access point to do? And that's essentially how the access points get their configuration in this Cat9800 model. Okay, so let's talk about this specifically around FlexConnect. So the steps to configure FlexConnect local switching, it's really pretty straightforward here. So the first one is we're going to want to go through step one. We're going to talk about configuring the remote site on the site tag. We're going to enable the WLAN for local switching. So we're going to configure that WLAN to tell it we want to do local switching as opposed to central switching back at the controller. And then finally, the last step we'll do is, as part of this step 3 here is we're going to configure the native VLAN on the FlexConnect AP, and we're going to tell the access point what VLAN we want that WLAN traffic to go into. So when traffic comes in on SSID-A, we're going to configure it and tell it we want to tag that traffic on VLAN 10 or VLAN 20 or whatever we want to do with that. And that's really the steps that are needed too. So we'll go into a little bit more detail, show you a couple of screenshots here. And this is actually showing the basic workflow on the Catalyst 9800. Ray is going to do a demo here in just a few minutes, and he's going to show us some of the more advanced workflow as part of this. But essentially what we're doing here on this first one is we're taking and we're enabling Flex for this particular site. So we take that site, we're telling it we want it to be a Flex site, and it's going to put that access point or that Flex profile onto that access point. The next thing we're going to do is we're going to go into the policy profile for this SSID that we're going to want to do, and we're going to tell it we want to do toggle on the central switching option and the central association option. So we're going to turn those off and tell it we want it to essentially do local switching for this SSID that this policy is going to be tied to. One quick note that I want to make sure that we talk about here really fast is that when you do toggle off central switching, so essentially telling the controller that you want this policy to be using local switching, you will need to do we'll need to toggle off central association as well, telling it essentially to do local association. When we turn on local switching, the AP handles all the association, so it has to be a local association there. Right now, you have to go and do them both separately. We're going to add a software fix for this soon that will automatically toggle those off for you when central switching is turned off. Additionally here, you'll notice too, we also have the ability to do central DHCP. Most times when you are doing local switching, you're going to want to do your DHCP locally as well. So you can turn that off as part of this too. So when you go into this policy configuration, and Ray will show us this in just a few minutes, we'll be able to see how we can turn these on and off and essentially tell the access point we want it to keep everything local at that site. And then finally, the final step here is to go and configure not only the switch port, so you'll notice over here on the right, I've got my gigabit interface here. I've got it configured as a trunk port. I specify the native VLAN. I have to identify that native VLAN on the controller as well. So we'll list that into the profile here, Flex setup, Flex profile setup, and tell exactly which native VLAN we want it to do. And then finally, the last thing to do is to go in and configure the WLAN to VLAN mapping. So again, we're telling it we want it to, for this particular SSID, remote SSID in this example, we want it to put it into VLAN 154 at that site. And that is basically it from a basic setup for that. So with that, I'm going to turn this over to the man who's probably sitting in his lab right now in his hammer pants talking. So Ray, are you ready to take over?
I am ready. I don't have hammer pants, though. Maybe back in the 80s I did. So, okay, so this is, I'm going to do a demo, basically what Scott just went over. So this, I just wanted to show you kind of the setup that I have here. So I'm mimicking like a central site where I have my 9800L controller, and it's on VLAN 1, 192.168.1. I have my Radius server, which is our identity services engine, and so that's all on VLAN 1 back at the central site. So I have a couple access points that have joined to the controller, and they're mimicking site A and site B. So what we're going to do is configure a central wireless LAN SSID, and that will be on VLAN 10. And now we'll run 192.168.10 address. Then we're going to do that local SSID where it's locally switched, and we'll just do a simple WPA, a static WPA PSK, for authentications, and encryption. And we'll see that will be on VLAN 20. And then the management will be VLAN 4 out at this remote site A. So this will be demo 1. I'm going to share my screen here. Can everyone see this? Scott, can you see that?
Yep, I've seen you.
Okay, great. Okay, so here's my controller. It's a 9800-L. I'm running 1732A code on it. I do have 2 access points, like I said, already joined. And like I said, this is going to mimic Site A. I have 2 different generations of APs just to show, too, that multiple generations of APs are supported on the 9800 in iOS XE. And then I'll have Site B, which is the 9115. So right now we'll just start with the 3802, which is Site A. I have a couple VLANs set up. One being the management, because we're back at that central site. And I have VLAN 10 and VLAN 11. So VLAN 10 is for that centrally switched SSID. So any device that joins the central SSID will be tunneled back through the CAPWAP tunnel and be assigned to this VLAN 10, because that VLAN is at the central site. It's not at the out at the local site. And then VLAN 11 will be on the on Site B. So our past session, the guys went over, the Radius server, but I just wanted to show you, just to reiterate. So I created my Radius server, my lab ISE. Like ArrowS, we create a group where you can have multiple servers all within a group. But I only have one, but with what's new with iOS XE is now we can create a list. So with that list, you can have multiple groups of multiple multiple Radius servers within each group. So I have that all set up. So we're going to go right to the setup. So this is the advanced workflow. So the session before, they went over the wireless profile, the policy profile, and the policy tags. But now what we're going to do is add that flex profile and the flex site tag. And the flex, that's really where you configure the flex settings, and you add it to the AP, which makes the AP go in from that local mode to Flex Connect. So one thing I do want to show you here, which is different than ArrowS. So we have our access point. It joins local like it always has. But in ArrowS, you could go in here and change this to Flex Connect. That option is no longer available. You have to have that tag tied to the AP in order for it to switch over to Flex Connect. Just another difference for you. So let's go back to the workflow, and we'll start with our wireless LANs. So I'm going to set up. This will be like a corporate-wide SSID. I'm going to call it Central because we're going to use it for centrally switched. Just to make it a little different, I'm going to say it's a 5 gigahertz only wireless LAN. We're going to do 802.1x, and I'm going to add that ISE AAA list. So that is my central SSID. Now I'm going to add my local SSID, which will be locally switched. And with this, I'll make it a 2.4 only SSID. So maybe it's for printers or something, some sort of device that doesn't have to go all the way down to the central site and then hairpin back. So we're just going to locally switch it. And I'll just do a standard, standard WPA PSK key. Sure I do it right. Okay. And now, so now we have our 2 SSIDs. Now I need to create the policy to say, what am I going to do with this SSID? How is it going to behave? Now this could be just one policy, depending on how you have your remote site set up. I'm going to set them up individually because I'm saying each remote site is different as far as as far as configurations and VLANs and whatnot. So I'm going to do Site A, Central policy. And we're going to keep it with central switching. We're going to send all the data plane and control plane all down the CAPWAP tunnel. The authentication is going to be central, so the controller is going to be doing all the authentication. The DHCP is at the central site. So everything is just heading down we're just sending everything down the CAPWAP tunnel. So here is where under access policies, I'm going to assign that VLAN that the controller knows about, because this is all coming back to that central site. And you can add, different QoS policies and whatnot as well. So now I want to do that Site A local policy, because we're going to treat that traffic different. So I will do Site A local policy, and I'm going to turn this off. And now we're going to do that locally switching. All that data plane is going to stay out at that remote site. And like Scott said before, we have to turn off that central association as well. But I'm still, just to keep this a little different, I'm going to say we're going to use the DHCP server back at the central site for DHCP. This site doesn't have a local DHCP. Now here, under the access policy, the controller doesn't know about the VLAN out at the site. So we have to type in what VLAN we are going to use. So in this case, we're going to use VLAN 20. So now we created our wireless LANs. We have our policy. Now we need to tie them together. What SSID is going to use which policy? So that's what this policy tag will do. So I'll name this Site A policy. And here I'll add my wireless LAN profile, central, and I'll tie it to central policy. And then I'm going to add my local, and I'll do my local policy, tie that to the local policy. So now we get down into that flex profile. So this is just kind of your standard setup, but now we're going to change it over to flex. Now what do we need to do with the flex? So I'm going to create this as a Site A flex profile. And now that native VLAN out at Site A is VLAN 4, so that's where I assign that. And over here you can see this is the features that you can turn and turn off on the with Flex Connect. So and now I want to add the VLAN. So we in the policy we said in the local policy we need to use VLAN 20. Now we have to say in the Flex, okay, we're going to use VLAN 20 out at that site. And VLAN 20. Now we don't have to put the 10, that VLAN 10, because that is centrally switched and the controller knows about it. And then we're just pushing this out to the AP. So now last step is we need to create that site tag. So we'll call this Site A flex tag. I can type. There we go. And we want to uncheck the local site to get the flex policy, the flex profile drop down. We select the Site A flex profile and apply to device. Now this is optional, but especially when you have a lot of remote sites, VR profiles. I mean, you can come in and create your own, depending on which band. You can come in, what data rates you want to clip or which data rates you want to use. You can change RRM configuration, channel widths, power. Just for time's sake, I'm going to create one because each remote site has different RF environments, different client counts, just depending on where they are. So I'll create one just to keep things different. But I'm going to use the pre-canned, the already configured ones. So I'll do Site A RF tag. And let's just say it's a high density on the 5 gig and high density of clients on the 2.4. I hit apply. And now our configuration's done. Now all we got to do is push it out to the access point. So now we select our AP. So this is my site A. I said, okay, this is the config I just did. I'm going to tag with my site A policy tag. I'm going to tag with my. I'm going to make it a flex, and I'm going to use my RF profile. So when I hit apply, now that sends it out to the AP. The AP will reset. It does a quick reset. And it will pop up here in 1 second. And so now what's going on is the AP is going to switch over to that Flex Connect mode, and you'll see the policy tags be added to it. Okay, so here it's back, and you can see here now AP is in Flex mode, and you can see our site tags are now assigned to that access point. So now saying that, if I go in here, and I remember when I said there wasn't an option for Flex. Well, now there's not an option for local. You have to remove that tag in order for the AP to go back to local mode. One other thing here, it's kind of a nice little check, is this AP operational configuration viewer, and it kind of gives you the thumbs up if you've configured it correctly. So we have a bunch of green, so it looks like we're good. Everything that we did, it looks good. So now let's test. So I have a couple clients here I would like to join. So here's my first one. I'll join the central SSID. Actually, I'll do the local one first. And then I hit refresh, and you can see here I have my client on. It's got the 192.168.20.11 address, and I can come in here under client detail, and you can see it. You can see the profile we're on is local. We're on VLAN 20. The Flex Connect data switching is local. DCP is central. Everything that we configured. So that looks to be good. So now let's join the central on another device here.
And you can see that local is on VLAN 20, so it is assigned it directly off the access point data plane.
Okay, got my certificate. All right, so now when I join, I join this guy. And you can see here it's 192.168.10.14. So we joined that central SSID. It tunneled us back to the controller. And if I go into my identity services engine, you can see here it's the RA Geyer joined. And you can see the Lab 9800, the controller is the authenticator. So that's demo one, and I'll hand it back to you, Scott.
Sounds good. Thank you, sir.
Oh, one other thing I would just real quick. I'm sorry. Here you can see we joined. I made the local 2.4, and then I made the central one 5 gig, and it shows that as well. So our configuration is correct. I'll hand it back to you, Scott. Thanks.
Good job. All right, let me steal the ball back here. Oh, I got it. There we go. All right. Go back to. All right. Well, thank you. I hope that was a nice demo. Wanted to kind of show some of the backup, some of the things we've just been talking about by showing you guys how it was all configured. All right, so let's get into this a little bit more detail around site tags. I did take a quick look at the Q&A panel while Ray was doing the demo, and it sounds like there's a lot of good questions coming up. Hopefully, we'll answer a lot of those in the next 45 minutes or so as we kind of roll through this. But I'm going to go through some more details around this. So Let's talk about site tags a little bit. So Ray showed us how we create that site tag a few minutes ago. That is really key to kind of understanding how FlexConnect migrates over from the ArrowS. So a site tag really takes the place of those old FlexConnect groups we had in ArrowS. So that's kind of the equivalent that you want to think about. When you start looking at site tags, again, they offer a lot of different functionality, very similar to what those FlexConnect groups did in ArrowS. So, the main things are the AS11R fast roaming key, CCKM keys are distributed to all of the APs that are part of the same site tag, local backup radius servers, the local EAP authentication, any AAA override that we'll be doing, smart image upgrade, which I'll go into in a few minutes, and FlexConnect AVC are all distributed to all the APs within a site tag. So what you're going to want to do is make sure that at each location, all the APs that need to be part of the same group are put into the same site tag. Now, I mentioned earlier that we do have a limitation of 100 APs per site tag. That is the exact same we had with ArrowS. It was 100 APs per FlexConnect group within ArrowS. The same restriction does apply with iOS XE. When you're looking at the various levels of controller platforms, so the 9080 does support 6,000 FlexConnect profiles. It essentially flows with the number of APs that are supported by that platform. Now, that's not to say that we recommend creating 6,000 FlexConnect profiles. That would be a single FlexConnect profile or site tag for every single access point. While it will do that, we wouldn't recommend that, but it certainly can scale up to higher limitations than we had with the previous platforms as well. The 9040 supports 2,000 and the 9000L supports 250. The cloud-based models go in line as well with that. I think it's 6,000, 2,000, and 1,000, depending on if it's a large, medium, or small instance that you're putting into. So a little more details around site tags for FlexConnect deployments. So what we do recommend here is that, like Ray showed us a few minutes ago, if you're going to put a Flex profile on a site tag, you have to disable that enable local site checkbox. That is a bugaboo that catches a lot of folks when they're first putting this together and they're asking, why is that Flex profile not listed on that site tag? Just uncheck that local site option there and you will have that option. Like I said earlier, the site tag is the equivalent to the FlexConnect group, and there are limitations against 100 APs per site tag. Roaming across site tags for Flex APs will result in a full client reauth, so that is something to think about when you're designing your branch locations. If you do have situations where you have more than 100 APs at a particular site, you're going to need to create multiple site tags for that location. Try and think about your roaming domains in those situations. We don't want to mix and match, APs that are next door to each other in different site tags. If we can avoid that, you'll typically want it to be one part of the building or potentially a floor type setup or something like that is what you want to look at. So try and look at it based on roaming domains and put APs together in the same site tag that will have clients roaming between them. A couple other recommendations when we start looking at creating these site tags for the branch. For FlexConnect, site tag is the roaming domain, right, like I just mentioned earlier. So if you want to have that fast roaming capabilities, make sure those APs are in the same site tag. You will want to configure at least one site tag per Flex site, and we do recommend that you don't use the same site tag across multiple Flex sites, and that includes the default site tag. If you guys remember, part of the conversation last week was dealing with these WNCD processes and some of the things that happen with that. If you don't, I'll refer back to the presentation from 2 weeks ago. Go back and listen to that. But the recommendation is to create a different site tag for every site that you're using. That kind of spreads out the levers across multiple different processes inside that controller. If support for fast seamless roaming, like we talked about, AS11R is there, the max number of APs again is 100 per site tag. And we kind of alluded to this already, but essentially what ends up happening with when you create a site tag is those AS11R keys are distributed to all of the APs in that site tag. So what this allows for is fast roaming. So when a client roams from AP1 to AP2, as an example, they're all part of that same site tag. The keys have already been distributed out to each one of these APs so that roam can occur and happen much, much faster and allow for that fast transitioning capabilities. Very key for voice deployments a lot of times, or things where we have clients who are sensitive to roam times. You want to make sure that the ability to fast reassociate or fast transition is enabled for those devices, so you don't have drops in packets, that kind of thing. Okay, so let's talk about designing a resilient wireless branch network and what goes into that. When you're starting to think about kind of designing your branch solution, you're going to need to think about sort of the resiliency capabilities and what do we want to guard against and what do we want to build for, for these particular sites. And you need to look at each one of your sites and determine whether or not, if there are applications in those sites that need to be up for that site to be running. Can we take a WAN outage or can we take a controller failure? What do we need to have in place from a redundancy standpoint? If this is a distribution center or a warehouse or something like that, then that needs to be up. That wireless needs to be up and running. The scanner guns need to be working, or that facility is completely down. Then maybe we want to take into account different resiliency capabilities built into it. So when we look at this one here, so this is going to go through sort of a WAN failure scenario here. So now I've got, in this particular case, I've got my central site, I've got my controllers located at the central site, I've got APs that are being managed via FlexConnect at this remote site location, and I've got multiple SSIDs. One's a centrally switched SSID and the other one's a locally switched SSID for my scanner guns. In this case, that's signified by the blue. If I had a WAN failure, in this case, let's say that this location goes down, I'm no longer able to access it. What's going to end up happening here is that central SSID, I no longer have access to it. That is going to be disconnected, but the locally switched SSID and those clients that are connected to that AP are still going to operate. That AP will go into what we call standalone mode, and it will still allow the clients that are authenticated on that access point to continue to operate at that site. Even for a roam, when this client comes back on to the other AP, because those association keys have been distributed to all the APs, that client is still able to roam and that site is still able to be accessed for that local SSID. Okay, let's take another scenario here. Let's say we're looking at a scenario where we have a primary and secondary controller in what we call our N+1 HA model. So we've got two controllers sitting up at our central site. They're not put together in that SSO mode, which I'll go through in just a minute, but they're two separate controllers that are managing this. In this case, let's say we suffer an outage on that primary wireless LAN controller. What will end up happening is that central SSID will go down for the period of time that it takes for that AP to move over, but you'll notice that local SSID still maintains and stays up during this time. As the client roams to the other AP, he's still able to operate because he's using that locally switched SSID. And then now as these APs come back online and are now talking to the secondary wireless LAN controller after a period of time of the discovery process to occur, depending on your timers, anywhere from 20 seconds to about 60 seconds or so for that to happen. As soon as that comes back online, that central SSID would be up and operational as well. So this is another way to kind of build in a little bit of redundancy for a controller failure at that central site. Another third option here is if you have situations where we want to do what we call APSSO or stateful switchover for the high availability. And this is really where the two controllers, in this case, would be physically linked together. They actually have a Ethernet port going between the two, and they effectively operate as a single controller platform that we'd be talking to. In this case, I've got, again, my two SSIDs, my centrally switched SSID and my locally switched SSID. I'm talking to, the APs are talking to the primary controller. In the event that primary controller goes down, the APs automatically switch over to the secondary controller. It's a stateful switchover, state, client sync, AP state, client state are all synced between the active and the standby controller. The APs are completely unaware they're even talking to a new controller. The IP address migrates over from the primary to the secondary, so that tunnel stays up. So in this case, when this happens, that centrally switched SSID as well as that locally switched SSID continue to stay up across that failure. Okay, let's take another situation here. We want to talk about AAA survivability in this case. So one of the things that Ray showed us is that we can configure multiple Radius servers inside. So we can have a primary and a backup, or we can have multiple AAA servers. So let's say we have a location or a site that is very critical to us, right? Maybe it's that distribution center or that warehouse or something like that that needs to be up and operational at all times. In that case, you may want to consider having a backup Radius server at that location. So in the event we had a WAN failure, as an example, we lose connectivity to our central site where our controller is, where our central Radius is. What we could then do is we could actually specify a local backup radio server at that site. So this could maybe be in an ICE world, a PSN is located at that critical branch site that we have. What can happen in this instance is that as a new client comes online, that AP could be that AP can be configured to actually use the local backup radio server as a secondary radio server to authenticate those new clients. So this is a situation where we may want to have some additional redundancy built in for these critical locations. Again, there are pros and cons to each of these approaches. You need to kind of weigh the requirements of that branch site against the cost and the amount of effort associated with doing some of these redundancy mechanisms. And here we can see fast roaming is also still supported because we are using that local SSID. This is a couple screenshots here of how you can do it. You kind of saw this a few minutes ago when Ray was walking through this. So as you go through and create that Flex profile, what we are able to do is actually specify the radio server group that we want to be used. Ray showed us how he had that server group configured before. He only had one server in his lab at this point in time, but if you did have multiple servers here, he could be listed as part of that the method list that we would want to use for this location. Okay. And then finally, there's another option here. So if we wanted to enable local authentication at this site, so in other words, we wanted to make sure that if there was a WAN failure scenario here, we wanted to make sure that those APs could authenticate to that local site radio server. The way this effectively would work is we would tell, again, by default, the way things operate is that the authentication is central. And you kind of noticed when Ray was walking through that demo earlier, we had central authentication that you could toggle on and off. One of the things we could do is we could turn it to be local authentication for the site. And what will happen when we do that is this Flex site would actually use a local radio server as its primary radio server. So if you want to keep everything local at that site, not even tunnel authentication across the WAN connection back to the controller in the central site, we can absolutely do that. We can support a local radio server as well. This is where you would do that. So you can see here the toggle for, we kind of talked a lot about the central switching and the central association, central DHCP. This is where we toggle off central authentication. And with that, we are to demo time 2. So I'll give it over to my minion, Ray, to kind of walk through the next part of the demo.
Okay, so the next slide shows, okay, so we did site A in the demo 1. Now we're going to do site B. So it's going to be the same basic setup, but with the central wireless LAN, we're going to change the VLAN to 11 because it's a different site. The local will be now 21. But we're going to add a site-specific SSID, just what Scott was talking about. It's going to be the local authentication, where the AP is going to be the authenticator. If it's for devices out there that if we do lose a controller or lose a WAN link, somehow the AP cannot talk to the controller, the AP will take over, and those devices will stay on the network and can still authenticate, roam, and function as normal, even though the controller is not available. So that we'll configure that. And the management VLAN out at the remote site B will be VLAN 5. Okay, so I'm going to share my screen. So I did have to turn off my 3800 AP, my site A, so I can focus, so I join the right AP. But so we will go do the same setup that we did before, but we're going to do it for site B. So we'll go through the workflow. So we have our wireless LANs, they're central and local, which are the enterprise-wide SSIDs. Now we're going to add a site-specific. It's the one that just happens. You need it out at the one site. We'll say site B. And I'll make this. I'll leave it at. You can use 5 gig or 2.4. Now we're going to do 802.1x. But since this is it's going to be local authentication, I don't have to put check my ISE list or my radius server here, because we're not going back to the controller. We're going to do it in the Flex profile. So we have site specific. We add our third SSID. So now we got to create a policy for each site here. So I'm going to do site site B, central policy, keep it the same. That's our centrally switched. But here we're going to change the VLAN to 11 this time because it is a different site. I'm going to create a site B local policy. And we're going to do the same. It's going to be locally switched. We're going to have central DHCP. And here we're going to change that VLAN out at site B to 21. Now we'll add that site-specific policy. Oops. Site B. Now we're going to turn off all this because nothing is going to go back. Only the control plane is going to go back to the controller for, like Scott said, for RF monitoring. Just basically just making sure the AP is online and doing all the RF information. But all the data is going to be local. The authentication is going to be from the access point. We're going to have a central or DHCP is local to the site. Everything's local to the site. So that VLAN, since the controller doesn't know about it, I'm going to make that VLAN 30. So now we need to do a policy tag tying all these together like we did for site A. This will be site B. Policy. And same thing, we're going to select our central SSID and tie it to site B, central policy. Add my local to my site B local policy. And then I will have my site specific and tie that to my site specific. Okay. So now we're going to have to do the same for the Flex profile. So I'll name this Site B Flex profile. And then the native VLAN is 5 out at the site. Now this is where we say, okay, for local authentication, I want to use this group. We can only use one group. We can't use the list, but we'll use the group. So this is where we tell the AP which group of Radius servers or Radius server to use. Now here we're going to add the VLANs like we did. This time we're going to add VLAN 20 and VLAN 30. Those are the two local VLANs out at the site.
What is VLAN 21, Brett?
Well, I'm sorry. Yeah, you're right. Sorry. Good call. Good catch. Yep. And I spelled it wrong too.
I wasn't going to correct you on that one.
VLAN 21. Okay. So now we need to do this the site flex tag as well. So I will do site B flex tag. Uncheck the local site. We'll select site B. Apply. Okay, so now we can create another one. Since we did it on the first one, I will create another RF tag. We'll make this one site B RF tag. But we'll say this is low density of client density for both, just to have something different. Okay, so now we have our config. We added that new SSID, added new policy to it. So now we just select our AP, which is our 9115 for site B, and we will add the tags. Okay, so now that will reset. Once that comes back up, we can test and see how we did. So once again, the AP will do a quick reset. It will move from that local mode over to Flex, and we'll see the new policies pop up.
Now, one thing to point out here, guys, is that Ray created new policy profiles, new Flex profiles for everything. The nice thing about the 9800 configuration is, it allows for that flexibility. But if we wanted to reuse, if there was similar policy, similar things used across a bunch of different sites, you can actually reuse a lot of the functionality. So it kind of keeps that template model in place. Sorry, Ray. I was trying to fill for you there.
Okay, so all of our AP's back. You can see here it's Flex. We have our Site B policy tags. So let's just do a quick little test. I'm going to do the local one. Now we'll go to clients. Okay, so here I have 192.168.21.13, and I will try the central one. Central. You can see I added it to 10. Anyway, this should be 11. I put the wrong. But you see what I mean. It when you do the central, it goes back to the controller. I should have switched that over to 11, but that was my fault. But same, it works. Now the last one, we will do the site specific. And that is the local authentication one. If I do site specific, now you can see here 192.168.30.14. So, and if I go to my identity services engine and look at my logs, so you can see I logged in on the central SSID, and like I showed before, here's the authenticator is the controller because we were doing the central auth. Now you can see Scott Clayton logged in, and it's from the site, and now it's coming from the access point, from that local authentication. So we had two authentications, two different ways, and it works fine. So now the next thing we're going to do is I'm going to simulate a failure, a WAN failure, a controller outage. I'm going to unplug. What's going to happen is the AP is going to go from that Flex Connect mode to the connected mode to the standalone mode, and you'll see once the AP, I'll have a client join, even though the controller is out of the picture. The AP, that site is still working. So if I unplug my controller, and I have if I have a ping going here, say the controller's out of the picture. So if I join site specific here, I will join as me. I should see a new request. So here's our Geyer. You can see it's coming from the AP, the radio interface. But if I look at my client detail, it's coming from site B9115. It's coming from the access point. So the controller's down. It's out of commission. I'm still able to join clients. The clients that were on are still connected. So let's try paying 192. $30.14. Well, maybe I can't pay them there. But anyway, as you can see, I joined the client with the AP down. So now when I plug the controller back in, now this will take a second for the AP to join back, but it will update the client list, and you'll see everyone that's joined outside of the when the outage happened, and you'll be back up in business.
So yeah, once that controller comes back online, what will happen is that AP will switch out of standalone mode and go back to connected mode.
Correct.
And be managed by the controller, and you'll start to see all the client stats, everything that had happened while it was in standalone mode will be updated here in just a sec.
So that's demo 2. So I'll hand it back to you, Scott.
Awesome. Thanks, sir. I appreciate it. There we go. And we'll go back to the slides here. Thanks again, Ray, for that. That was good. So hopefully that kind of shows you guys how we can plan for survivability in this case. Ray showed kind of a controller outage. What happens in that case? We also showed kind of the ability to do a local authenticator. So again, for those critical sites, if you need to have the authentication and that site stay up, even against a WAN outage or a controller outage or whatever outage, there's lots of kind of resiliency options built into some of the flexibilities. All right, so let's get into some of the more advanced configuration capabilities in this last 25 minutes or so that we have. So I really want to talk about, and I saw a couple of questions in the Q&A around this. So we do support AAA VLAN assignment as part of this. And this is something that comes up a lot with a lot of our customers. So we do have the option, just like we do with local or essentially switched SSIDs, we can actually assign via AAA VLAN override, we can assign a client to a specific VLAN. So the change of authorization capability is supported with Flex as well. So up to 16 VLANs per FlexConnect AP are supported. The VLAN ID must be enabled per AP or FlexConnect group, or in this case, site tag. I should have updated that slide there. So in this case, let's say we got a client that joins a FlexConnect a site, that's part of the site tag, and we want to assign it to VLAN 3. What we have is a radius server responds back with the VLAN assignment, and the AP will put that server or the client into VLAN 3. In this case, we have another client that joins as a phone, and we want to assign it to VLAN 7. That VLAN assignment gets sent by the radius server down to the AP, and it puts that client into VLAN 7. So effectively, this is how it works. So we create our radius attributes. In this case, we're doing it on ICE to tell it exactly which VLAN we want to assign that client to when they connect in. On the controller, we could set the configurations here. There's an option here for AAA override that needs to be turned on that basically tells the controller to accept, or tell the AP in this case, to accept what the radius server responds back with as far as a AAA VLAN assignment or any other kind of AAA policy that gets returned. And then the last thing we need to do is set the switch port on that the AP is connected into to make sure that that VLAN that's getting assigned is allowed on the trunk going to that AP. So as long as all those things are set, then that AP will set that client into that specific VLAN. Okay, so in this particular case, we'll walk through this one real quickly here. Let's say that in this case there is a situation where we assign a VLAN that does not exist at the controller or at that switch or off the access point in this case. So what will happen in this instance is that by default, what we can do is we can actually set it so that the AP will tunnel that traffic back to the controller and put it onto VLAN 3. If VLAN 3 does not exist, or here in this case, all right, we're going to assign this to VLAN 7. VLAN 7 doesn't exist at this access point. Maybe there's the trunk port was not set up correctly, whatever it may be. That traffic gets tunneled back to the controller there. In that case, VLAN 7 doesn't exist at the wireless LAN controller. What ends up happening to that traffic? That traffic will be automatically go to the default VLAN ID for that SSID. So whatever's set up for that VLAN SSID, that traffic we put onto. So it allows for situations, there's kind of fallback methods here for situations where we may have had an incorrect setup out at the remote branch site. Here's where you configure that. So you can see under the policy profile here, we've got AAA override is checked on. That's telling the controller or the access point to allow for the settings that the AAA server is going to respond. And then VLAN central switching would be checked on there. That would be allow for, if that VLAN didn't exist, to tunnel that traffic back to the controller as a centrally switched SSID. Okay, so here's another scenario that tends to come up a lot, right? So I've got a situation, so going back to sort of Ray's design of that Site A and Site B, what Ray did was he created, VLAN 10 and VLAN 20 at Site A, and over on VLAN, or at Site B, he had VLAN 11 and VLAN 21. That does happen where you don't have the cookie cutter design set up in those situations. What a lot of people wanted to do was they wanted to map clients to specific VLANs based on their function. So let's say we have a user who joins Site A. This person is part of our marketing VLAN. The AAA server identifies that person, knows they're part of the marketing group, and we want to put them into the marketing VLAN, in this case, which is VLAN 20. So we respond back with VLAN 20 from that radio server. Now this user moves over to Site B. They connect to the network again. They get assigned VLAN 20. Well, in this case, at Site B, VLAN 20 does not exist. So how do we solve this particular problem? The way we do that is we actually create a VLAN to name mapping for this. So in this case, and Ray kind of showed us a little bit of this sort of accidentally as he was going through it. But for Site A, what we're going to do is we're going to create a VLAN mapping that says the VLAN name to the VLAN ID. And for Site B, we're going to do the exact same thing as part of this the site tag that gets assigned there. So in this case, now you can see that marketing on Site A is VLAN 20, but marketing on Site B is VLAN 21. So now when that user connects at Site A, they get authenticated. We're going to send back the VLAN name marketing. It's going to put them into VLAN 20. That user moves over to Site B, as an example. Now connects in, gets authenticated, returns back VLAN name marketing. Now at this particular site, the site tag settings are going to set, or the flex settings are going to stay to put that user into VLAN 21. So this is a way to kind of get around the situations where we don't have, again, that cookie cutter type design at each location. All right, let's talk about operations, because this is something that does come up a fair amount as we're getting into branch flex design. So some of these things have not changed from the ArrowOS model. There's still some WAN bandwidth requirements from a minimum perspective. You can kind of see listed here. I don't know how many really 64K links we have out there anymore, but for some of these sites where construction trailers, or maybe where you just don't really have a lot of bandwidth going to these locations, we can still support Flex Connect at these locations, but here are the restrictions around it, from a minimum bandwidth, maximum latency, that we support the number of APs and number of clients. So this is a good kind of reference chart. Don't need to write anything down or memorize this by any stretch, but as you look at these, if you download these slides, take a look at kind of some of these sites, especially for where you do have bandwidth restrictions. Just keep this in mind. All right, upgrading Flex Connect deployments has been a challenge for a lot of customers for a lot of years, so we've come up with a new way to be able to do this. Typically, when you're looking at Flex Connect sites, they're generally lower bandwidth sites. You don't want to use up all that bandwidth to upgrade all the APs at a site. You can kind of bog down that T1 connection, or whatever you may have at that location. So what we came up with, this idea was to do this efficient AP upgrade model, and I'll show you where that's turned on to. So basically, the way that this works is that it's supported, first of all, on all Wave 2, so all of the X800 series APs and all of the new Wi-Fi 6 APs, so all the Cat 9100s series APs are all supported for this. So basically what ends up happening is that the WLC elects a primary controller for each model type at each location, and it is responsible for effectively upgrading like its own APs at that site. So I'll show you guys how this works. A quick example here. So in this case, I've got 16.12.1 running on my wireless LAN controller and all my APs. I want to do an upgrade. So you'll notice I've got a site here that's supported. I've got Cat 9115s, I've got 1852s, and I've even got a 2802 at this location. I want to upgrade to 16.12.2. What will end up happening in this case is I'm going to elect that primary controller for each model type at this location, and they're going to be responsible for downloading that code. So the 9115 in this case grabs 16.12.2. The 1852 grabs it, and the 2802 grabs it. So in this case, I'm only distributing the code from the controller to these three APs at this site, even though I've got a bunch of different kinds of APs at this site. What ends up happening now is that 9115 is responsible for updating the AP. In this case, it's 9120. That's part of his same family. So he distributes the code to the 9120. The 1852 will update the 1815 as well as the 1832. And then the 22 he has no similar APs at this location. So at that point, we've downloaded that code only 3 times, but all 6 of these APs have officially gotten the AP update. So we actually leverage the LAN side of things to update half the APs in this example. The way that this is done is you may have noticed when Ray was running through the demo with the Flex profile, there is a checkbox here for efficient image upgrade that is just turned on. It is on by default, but you would have to turn that off if you didn't really want it. But it's a good thing to have in there, and that's kind of what it's referring to. Okay, let's talk about FlexConnect best practices here real quickly. So these are, I just want to kind of put these in here, and there's actually some really good documentation I have linked at the very end of this that kind of runs through some more details around this. But a couple things that we do want to make sure when setting up for FlexConnect. So enable FlexConnect profile. For voice deployments, you definitely want to make sure that your 802.11r, CCKM, OKC key sharing is enabled, especially for voice, like I mentioned earlier. When you have clients that require fast roaming capabilities, we want to make sure that this is set up. So again, configuring a single site tag, putting those APs into that same site tag will allow for that key sharing to occur. VLAN support and configure native VLAN at the group. You'll want to make sure you have that. So when you create those trunk ports that we're going to be, the APs are going to, these FlexConnect APs are going to be plugged into, make sure we have the native VLAN identified and we have all the VLANs on that trunk that we're going to want to support for that particular site or that AP. VLAN to WLAN mappings are done in the FlexConnect profile. Ray kind of showed us a lot of that. VLAN name override is another good solution there. So rather than depending on sending a VLAN number or VLAN ID down, use name override to make that happen. It makes it a lot cleaner for your various sites. Consistent configuration across primary and backup WLCs. That's kind of probably a little bit of a no-brainer there. We want to make sure if we do have a primary and a backup wireless LAN controller, the configuration stays consistent amongst those two. And this is referring to an N+1 model. Designed for resiliency, right? We want to make sure that we understand what these sites require, how critical they are, what needs to be up at all times, that kind of thing. And then the final thing is to enable efficient AP image upgrade. Don't use up all your bandwidth for these sites to download code to the APs. One additional enhancement I wanted to bring to your attention here is this. So this just came with 17.4. It's a very recent code. There was an issue in earlier code where we had overlapping IP across Flex sites. So let's say you had multiple sites and you wanted to have use the same IP address range at various locations. Well, what would happen in earlier versions of code, it would identify as IP theft alert. So it would allow the clients would actually be blacklisted. So it wouldn't allow for the reuse of DHCP scopes or address ranges across multiple sites. With 17.4, we actually do allow that now. So you can. So if you do have the situation where you are using the same IP ranges at multiple sites, make sure you grab this fix that's built into 17.4 that allows us to do it. And the way we do that is there is now a new checkbox here that you can see here on the Flex profile where we turn on IP overlap. So we'll allow for that. It won't blacklist those clients because of IP theft. So I thought that was important. I just want to bring that to your attention because it is something that's bitten several customers that I've been working with here recently. All right. Finally here, key takeaways. So, a couple things here, just to reiterate. Determine the best option for your branch design. I saw several questions in the Q&A panel, asking what the best solution is. The answer is they're all good, right? I mean, there's certainly pros and cons to every single approach. It just depends on your specific needs. So, take a look at what your specific needs are, what the sites are, what we can support in these locations, and understand, hopefully through this presentation and doing some reading, you guys can understand what the pros and cons to these are, and you can figure out what the best solution is. And always, feel free to consult with us if you have any questions on any of that. Maximum 180 piece per site tag. Hopefully I nailed that, or hammered that one home pretty well for everybody, to make sure that, there is a maximum 180 piece per site tag. Don't go over that. There are things that will happen, some of them unknown at this point, but definitely try and keep it under 108 piece per site tag. Design for high availability wherever you can, right? So we want to make sure from a resiliency standpoint that we're designing for any kind of outages that you may suffer, and want to make sure that we have contingency plans built into place. And then finally, the last one is leverage segmentation, the VLAN assignment capabilities. I wanted to make a point here that I had to cut out some of the sections here for time purposes around ACL, more of the security components that we had in here. So when you go to download the slides, there's going to be an additional section there that talks about applying ACLs to your Flex deployment too, if you wanted to add some additional security capabilities, do some different things there. So leverage security and segmentation wherever needed and possible. Finally, here are a couple of links that I wanted to point out here. The first one here I'll mention is the very top one. This is a Cisco Live presentation. So every year at Cisco Live, we do a branch office, so in this case, design and deployment of wireless for branch and remote offices. A lot of the information that I shared today actually came from this presentation. So if you guys have an opportunity and want to listen to someone else talk about this, you feel free to go to this link. This is from the 2020 Barcelona Cisco Live session, so we can actually, if you have access to the Cisco Live website, you can go and listen to the presentation that was given last year on this topic, or download the slides and look at some of the stuff that's there too. And another couple other good links here. There's a lot of stuff was what Drew and Kayor had in their slides last week, just good 9800 reference material. The only one I really added here was the Understanding FlexConnect on the 9800 WLC. I'll point out that one down here on the bottom right. That was another good one to be able to go and reference. Goes in a lot more detail around the various configs we talked about today. And finally, from a wireless promotion standpoint, I want to bring to everyone's attention that we do have the 50% off Catalyst 9800 series. So if any of this is interesting to you and you are ready to start making the migration from the AirOS controllers over to the 9800 series, there are some migration packages in place that will allow you to kind of get the hardware at a reduced cost. So speak with your Cisco representatives, partners, whoever, and we can certainly help with that part of it. And then last promotion I'll mention here is the first year of wireless DNA on us. So there are another capability out there to provide the first year of service for free as part of this too. So again, just work with your resellers or Cisco sales team on these options. And the last thing I'll leave you guys here with is the upgrading, the upcoming series. So again, we've now completed the first two. The next one will be in 2 weeks on the 9800 CL. Then we'll have the 9800 migrating Prime to DNA, and then finally troubleshooting tips and tricks, and then the lab portion. So please join us for the remaining upcoming sessions. We'd love to have you. And with that, I thank you for your time today, and hopefully this has been a valuable experience. Thanks.